Okay, class, picking up where we left off. It says, what is the slope of a horizontal line? Sketch an example. Now, what I did was I used the insert a figure here so it'll look a lot better than the last drawing I had. But this is a horizontal line. We know a horizontal line goes across from left to right. And this means that no matter what the x value is, y will remain the same. So your slope is 0. Okay, now we go here. It says, find the slope of the line passing through each of the following pairs of points or state that the slope is undefined. Indicate if the line is horizontal or vertical. Now we would take this. We would have our slope is equal to, now we know it's supposed to be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So this is 1 minus a negative 3, which is 1 plus 3, over 2 minus 2, which is 0. 1 plus 3 is 4, and our denominator is 0. So our slope is undefined. Okay, now for B, we use the same formula. We have the slope is equal to y sub 2 is negative 4 minus y sub 1 is negative 4 all over x sub 2, which is 3, minus x sub 1, which is negative 1. So negative 4 minus a negative 4 will become negative 4 plus 4, all over 3 minus a negative 1, which is 3 plus 1. Negative 4 plus 4 is 0, and 3 plus 1 is 4. 0 over 4 is 0. So our slope is 0. Now, one other thing you need to pay attention to is this here. If your x values are the same and your y values are not, your slope is automatically undefined. You see how both of our x's are 2? So your slope should be undefined. Now with our b here, our y's are the same, but our x's are not. Whenever that occurs, then your slope is automatically 0. Now for our next example, it says sketch an example of a line for each of the following types of slopes. Now I took the liberty of already doing that here, where you see this graph here, this line here, if you're going from left to right and a line is going upward, that means it's increasing, that has a positive slope. If you're going from the left to the right and a line is falling, that's a negative slope. You know, if the line is horizontal, it's 0. If the line is vertical, it's undefined. Now we scroll down here. It says use slope to show that lines are parallel. Two lines that do not and will never intersect are called parallel. These two lines must have the same slope. Now they want us to sketch an example. Now here's an example of two parallel lines. Now I know that these lines are never supposed to touch. And what I did was I changed the color so you could see the difference between the two lines. Now we come down here to example 6. It says determine if the line passing through negative 2, 0 and 0, 6 is parallel to the line passing through 1, 8 and 0, 5. Parallel lines have the same slope. So all we have to do is just find the slope of both of them. So the first one, our y2 is 6 minus our y1 is 0. All over our x2 is 0 minus our x1 is negative 2. 6 minus 0 is 6. 0 minus a negative 2 is 2. So here our slope is 3. Now we go and do the second slope. Our y2 is 5 minus our y1 here is 8. All over, we will add x2, which is 0, minus x1, which is 1. 5 minus 8 is negative 3. 0 minus 1 is negative 1. So this slope is also 3. So they are the same, so your answer here is parallel. Now, we scroll down to the second page. It says two lines that intersect at a right angle, 90 degrees, are said to be perpendicular lines. The slope of these two lines are opposite reciprocals. Sketch an example. Okay, class, here's a representation of two lines that are perpendicular lines. Okay, now we need to go down here to answer this question here. It says determine if the line passing through 1, 5 and 0, 3 is perpendicular to the line passing through negative 2, 8 and 2, 6. So remember, our slopes must be opposite reciprocals, one positive, one negative, and then reciprocals of each other. So let's do the first slope. Our y2 is 3 minus our y1, which is 5. And it's all over x2 is 0 minus x1, which is 1. 3 minus 5 is negative 2. 0 minus 1 is a negative 1. So our slope here is 2. Now we do the second slope. We have y2, which is 6, minus y1, which is 8, all over x2, which is 2, minus x1, which is negative 2. 6 minus 8 is negative 2. 2 minus a negative 2 is 4. We can simplify that. We could divide both by 2. And our slope is a negative 1/2. Now, first of all, remember, perpendicular slopes are opposite reciprocals. This is positive and this is negative. So it satisfied the opposite portion. Now we have to look at the reciprocals. The reciprocal of 2 is 1/2. So your answer here is perpendicular. And you could put lines there. So your final answer here would be perpendicular lines. Now, we scroll down to objective 4. It says calculate rate of change in applied situation. And apply situations. Example 8. If temperature increased from 60 degrees Fahrenheit at 7 a.m. to 68 degrees Fahrenheit at 11 a.m., estimate how much the temperature increased per hour. So, now for example 8, now it says again, if the temperature increased from 60 degrees Fahrenheit at 7 a.m. to 68 degrees Fahrenheit at 11 a.m., estimate how much the temperature increased per hour. So we need to write this out as an ordered pair. So what we would do is, first we would write the time. It's 7 a.m. is 60 degrees Fahrenheit. Next, at 11 a.m. Now you can write the a.m. You don't necessarily have to, but at 11 a.m. Oh, wait a second. Let me get rid of this parenthesis. Okay, now at 11 a.m. it was 68 degrees Fahrenheit. So now we have our x1. Let me put that a.m. there. We have our 7 a.m. 60 degrees Fahrenheit, 11 a.m., 68 degrees Fahrenheit. Now we just write it as a slope. The slope, remember, is the rate of change. So we'll do the temperature first. We will have 68 minus 60 all over 11 minus 7. So when we subtract this, this gives us 8 over 4. So our slope is 2 degrees Fahrenheit. That is the rate of change. Now you can write this down. The temperature changed about 2 degrees Fahrenheit per hour. Temperature change about 2 degrees Fahrenheit per hour. Now, example 9. Construction laws are very specific when it comes to access ramps for the disabled. The grade of a ramp refers to its slope, expressed as a percent. Every vertical rise of 1 foot requires a horizontal run of 12 feet. What is the grade of such a ramp? Round to the nearest tenth of a percent. So we have our slope. Now remember, earlier on, we found out what goes in our numerator and what goes in our denominator. Now again, on the first page of this section, we had the vertical divided by the horizontal. Now our vertical is 1 foot and our horizontal is 12 feet. Now we know the feet would simplify out, and then we would divide 1 divided by 12. Now after we divide the 1 divided by 12, that would give us an approximation for our answer. The nearest tenth of a percent will leave us at 8.3%. That is the approximation. Now we come to section 3.4, the slope-intercept form of the equation of a line. Objective 1, find the line's slope and y-intercept from its equation. The figure to the right shows the graph of the equation y equals negative 2x plus 3. It says, what is the y-intercept of the graph? Now the y-intercept, whenever you have y by itself, the y-intercept is the value on the other side of the equation that's not connected to x, and that number is 3. So we will write that as an ordered pair because remember, the x value is 0, and then the y value is your y-intercept. So your answer here is 0, 3. Now it says, what is the slope of the graph? Again, when you have y by itself, then you take the coefficient of the variable x. The coefficient of the variable x is negative 2, so your slope is negative 2. Now, this form is called the slope-intercept form of the equation of a line. The slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is y equals, it's supposed to be mx plus b. This is the formula. Now, for example 2, it says state the slope and y-intercept of each of the following. Y is by itself, so the slope is the coefficient of x, which here happens to be 1/2. And then your y-intercept, we typically write it as an ordered pair. So first I want you to write it as an ordered pair, which would be 0, negative 5. Or it could be written as b is equal to negative 5, because this lowercase b represents your y-intercept. Okay, next, we have b here. Y equals negative 3x. Our slope, because y is by itself, is negative 3. Our y-intercept, or we could write down b, our y-intercept, because there's no other number there, is 0. Or we could write it as an ordered pair. It would be 0, 0. Okay, now we come down to example 3. It says find the slope and the y-intercept of each of the following lines. Now if you notice, y is not by itself, so we need to get y by itself. So we will subtract 7x on both sides, and you will have y is equal to negative 7x plus 6. So our slope is negative 7, and I'm just going to start writing our y-intercept as an ordered pair. Our y-intercept is 0, 6. Now we go here to b, the same thing. We need to get y by itself. So we will subtract 3x on both sides, and we will have 2y is equal to negative 3x plus 3. Now we need to get this this y by itself, so we need to get rid of this 2 here. So we would divide all of the terms by 2. So you will have y is equal to negative 3/2 x plus 3/2. So our slope is a negative 3/2, and our y-intercept will be 0, 3/2. Now it gives us some helpful hints here on the next page about graphing y equals mx plus b by using the slope and y-intercept. It says plot the point containing the y-intercept on the y-axis. Obtain the second point using the slope, using the rise over run, and then use a straight edge to graph the line. So we come down here to example 4a. Use the slope and the y-intercept to graph the linear equation.